Welcome back to Calculus with Mr. Walton. Today we want to talk about finding area using integrals, not derivatives. So, make sure that we change our topic from derivatives to integrals. Hopefully you caught that. If not, here we go. First thing, let's review. How do I evaluate a definite integral? First, we remember to solve analytically using our rules for anti-differentiation. Here we go. We are going to change 4x cubed to 4x to the fourth over 4. We're going to change 6x to 6x squared over 2. And we're going to change 5 to 5x, and that would be over 1. And we are going to solve on the interval of -3 to 5. Before we move any further, let's make sure that we simplify. Once we have simplified, the next thing we want to do is plug in our b and our a. So we will have these two setups. Then we're going to actually use our calculator or our mathematical ability to solve and get 625 minus 75 plus 25. Combine all terms to get 575. Then we're going to subtract. $81 minus 27 plus 15. When we combine this together, we get a total of 39. So then we have a final answer of 575 minus 39 for an answer of 536. Next up, we want to look at our two concepts, net area versus total area. In net area, we're going to keep the signs and find the sum of all the areas. For total area, we're going to find the sum of the absolute value of all the areas. If we keep this in mind, it should make it easier for us to be able to do this. What you've done before, what we've been practicing, is finding net area. What we want to look at today is finding the total area. If you see total area, think geometry. Therefore, everything must be positive. So if I'm looking at this example, and I ask you to find the area of the region, y equals 8 minus 4x, on the interval of 1 to 6, inclusive, this area is indicating that we want a total area. Therefore, what we need to look at is what is occurring in our function y equals 8 minus 4x. First thing we do is find the zeros. If we do that, we have a 0 at 2. So we're going to calculate the integral from 1 to 2, and we're going to add it to the integral from 2 to 6. By doing this, we have divided up one side is negative, one side is positive, and we know once we calculate this, we can find the absolute value of whatever numerical values we have and add them so that we have the total area. Therefore, let's go ahead and integrate, and we will get 8x minus 2x squared from 1 to 2 plus 8x minus 2x squared from 2 to 6. Please note that we get the same exact function when we integrate. So we're going to get 16 minus 8 minus 8 plus, minus the quantity 8 minus 2, so that I get 8 minus 6, which is 2, plus, I'm going to plug in, I'm going to get 48 minus 72 minus 16 minus 8, so that I get negative 24 minus 8, which is negative 32. We're still going to keep our addition. The one change comes now. Take the absolute value of both terms so that our answer is the total area.